Hey guys, for day 2, semester 2, Alex, you're going to be talking about mean median mode again, which we already covered yesterday, but we're also going to talk about outliers and probability today. So I have hopefully a helpful way for you to understand those. So, what is an outlier? So here's an example question that you might see on Alex. We'll talk about how you solve it. So in this example, there are 10 people on the swim team, and they each swim the following number of laps during practice. So here's a list of the number of laps. So 18, and then 73, and so on, up to 186. It says identify all values that are outliers. These are the type of question you'll see on Alex. It says if there's more than one outlier, separate them with commas, and if there are no outliers, answer none. So what is an outlier? Well, an outlier is defined as a data value that is much smaller or much larger than the other values in the data set. So it's a value that's unusual in size. And exactly what unusual in size means depends on what values you're looking at. The other way to think about it is an outlier lies outside most of the other values. So let me show you what that looks like. Here is our list of 10 numbers, 18 all the way down through 186. And if you put them on a graph, you can pretty clearly see these numbers in the middle are all pretty similar. So 73 through 93 are all pretty close together. And then we have this number that's way outside, 18, and another number way outside, 186. I think this is a helpful way to visualize an outlier. You can see that they obviously, just visually quickly looking at them, don't fall within the rest of the data set. Why might this be useful? Well, think about it. If you're the swim coach and you see that, Johnny and Susie and, Mike all swim between 73 and 93 laps, you're like, okay, they had a pretty good practice. But if you see that, Tim over here did 18 laps and that's it, maybe he's injured, maybe there's something wrong. Or if you see that Michelle did 186 laps, well, maybe Michelle did something crazy, that made her do 186 laps. Maybe she didn't understand what she was supposed to do for practice. So an outlier is useful in that way because you can see that it's way outside of the other values. So back to that same question. Here's our list of numbers again, like you'd see them in Alex. Since there are 2 of them, 18 and 186, you'd answer that 18 and 186 are outliers. Hopefully that makes sense. Easy enough. Next, here's an example. Okay, so you can see you've got 11 participants in an experiment for their reaction time. Here are the list of values, and see if there are any outliers. I'm going to pause the video and see if you can figure it out. Okay, so if you look at all of these, they're all pretty well grouped together. 506 and all the way down to 481, all pretty close together. 878 is like almost double most of these values, so that would clearly be our outlier. Okay. Next, you're going to have questions about probability. That's what you're going to be moving on to in your Algebra 1 class. So here's a question. It says a spinner has 10 equally sliced, each equally sized slices as shown below. Like if you're playing a board game or something like that. The dial is spun and stops at a slice at random. That's important. None of these slices are more likely than the other. It says, what is the probability that the dial stops on a gray slice? Write your answer as a fraction in simplest form. So the way we determine the probability of a random event is like this. So it's the chance of the event that you want to happen. Here that's the spinner lands on a gray space over the total options that you have. So specifically, that'd be the number of gray slices over the total of slices overall. So here you have 2 gray slices and a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 slices. So your probability is 2 over 10. We could leave it there. However, it says we want to write our answer as a fraction in its simplest form. I can simplify 2 over 10 by dividing the top and bottom by 2, and you get 1/5. Okay. I'll let you try another example. I'll pause for just a second. Okay. Hopefully you've had a chance to read and answer this question. Here, same probability definition, the number of gray slices over total slices. Here that's 2 over a total of 6. Don't get distracted by the fact that there are white slices and black slices. Here we just care about the total gray over the entire total. That's 2 over 6, which simplifies, of course, to 1/3. Last, an example here where we're going to use marbles instead of a spinner. Now we're assuming it's basically the same situation. You can imagine these marbles inside of this bag being just like the spinner wheel. So here it says a bag with 6 marbles is shown below. A marble is chosen at random. It's really important that it's done randomly. Imagine reaching your hand into that bag, blindfolded or something like that. What's the probability that one is white? So it's the same type of question here, and I'll let you try to answer it. Great. The answer here will be there are 2 whites out of 1, 2, 3, 4, 5, 6 total ones. So 2 over 6, just like before. 2 over 6 is 1/3. Hopefully that makes sense. Please reach out to me during my office hours or by email if you have questions about how to answer probability in ALEKS. Thanks. Good luck, guys.